Depending on what you're doing, it's as usable as anything else. It depends on how much you
I've done this one before, we'll do it again, it was good. And I like to see people's eyes roll. As most of you guys know, turn on your OS2 box, it runs until you stop it, or it stops on its own. But usually it runs for longer than that, so that's pretty good. But when you have problems, you've got to look at things. And it's a good idea to know how to look, and also it's a good idea to know what you're going to be, recognize what you're going to be asked to give folks. Because, you're not developers, you're not really expected to be able to fix this stuff. But you're sort of expected to be conversing with the tools that are available, so when someone says, give me the process dump, you can actually do it. But anyhow, OS2, when it has a problem, does one or two things, depending on where the problem occurs. One of your what we call ring 3 applications, things like Firefox or the editor or whatever has a problem, you will get an exception. And you'll get a couple types of exception reports available. One is standard old process exception, and usually you'll see it in your pop-up log, or if you're unlucky, you'll see it at the command line. If you're using GCC. And then the other one, which we don't like to see we don't see too often anymore, and we really don't like to see it at all. That's the kernel. When the kernel gets a problem that it doesn't know how to get out of, it just says, I'm dead. And the assumption is this is IBM's way. Rather than trying to just go on, it says, well, I might destroy data if I go on. So it's really better if I just give up and maybe destroy data that way. Well, you're never sure. Now the other place is now there's a bunch of other exception reports you get, which are typically generated by applications. One is except queue, which we'll talk a little more about later because they're getting pretty pervasive and they're almost human readable. Developers don't have any trouble. Some end users can read them. But then there's also GCC Live C exception report. Those are the ones that if you're running a command line application, they come out of the command line and say you should really be running a process dump now. Now, if you're running a GUI app, you don't see anything. You just know your app's dumped. That's the case where, for instance, if you're running Firefox, a lot of times they'll tell you to use run with logging, so that at least you can see the exception report. This is in the old days. These days, Firefox has full except queue report, so it's not as needed. But except queue, because of the way IBM implements exception handling, except queue cannot always run. The application needs enough stats so that basically OS2 can call the exception handler and let it process. And if it doesn't have enough stats for that, then you'll fall back to the pop-up log, or in the case of GCC, you won't see anything. And another product thing we use a lot is FT Workplace. It's there, it's usually unnoticeable, but it's there and making your suite and making your desktop look better. But every now and then you may hear a beep. And that usually means you should go look at your except queue log. Or no, excuse me, your T Workplace log. I think of them interchangeably because it's almost the same code that's sort of forked out. If you look at the except T Workplace log, you'll see all the same similar data items because it all came through the original IBM written except queue code. And then we don't have this one too much anymore because we're not using it as much. But the Initech font library has its own exception handler too. So if all of a sudden your desktop hangs up and it looks like a font problem, go hunt down the log. And I'll talk about a little bit more about where to go look for these things later. Oh, another thing that I should mention, exceptions are not really fully stated. IBM has this interesting thing they call even things that are realistically just notices, exceptions. And it happens to us programmers too. They have a whole bunch of things that are under the error class, DOS error this, DOS error that, and they're not. They're simply notices that something happened. And usually it takes a while to understand that, but I've had guys say, well, I'm getting this exception. It doesn't matter. It's just a notice. It's not an error. And what should have happened is the application should have never reported it. Because actually, when those things show up, it's an application reporting error. Or a user error, like in the case what Greg was mentioning, where he was getting except queue reports because the application exited normally. Because there are cases where you actually want except queue to do that. And I'll talk about that a little more later, but in general, you don't. And just for 1 second, let me get my pointer. That's a battery.
Is it red?
Your standard process exception report generated by the kernel is that. And it'll show up in your pop-up log. This is all nicely documented in the debugging, in the OS2 debugging guide, which you all have as part of your ECS distributions. And if not, it's downloadable to those places. But basically, it's just telling you died, the type of error. And this is important. That's actually an error. But if you see something like a C101 or something like that, it's not an error. That's a notice. Unless it shouldn't happen. Well, one of the things we have every now and then when we're doing ported applications, like the last one I did was Apache, and programmers would very nicely stick an exit statement in the case where they got confused and didn't know what to do next. And of course, things would shut down without any logging, no messages, no nothing, which was the incentive for actually putting the G option in except queue. Because then I did get reports with the C101. We said, oh, that's where it went from. And then we took that code out, made it do something else, and no longer silent, there was more silent exits. This is the bad boy here. You get one of those, it's time to reboot, check disk, and hope your drive is still okay. Fortunately, unless you're really doing a lot of intensive disk activity, you usually survive that check disk. But what you're seeing here is that's where the error occurred. What happens is people tend to, instead of writing all this down because they didn't have a camera or they forgot to use it, they write down this, which is useless. Don't send me that. I will chide you or ignore you, one or the other. Because this is actually just the place where it stopped in the kernel, which has absolutely nothing to do with what actually caused the problem. There's about 5 or 6 of these places in the kernel, and it says, oh, okay, I gotta stop there. This number is actually useful, but there is no cross-reference. There are ways to look it up, but it's not as much fun as you might think. What it really represents is a module name and a line number. And these are, IBM has cross-reference to this, and they won't give it to us. And they won't give us the source either, so I don't have the line numbers.
Yeah.
But the benefit is you've got to disassemble. If you have the kernel in the kernel debugger or something like that, you can go searching for that stuff. Because this stuff here is usually close to that address, just because of the way the thing calls it. Oh, for those of you who are familiar with IBM stuff, it's sort of like an old mallet. Pushes the values on into registers and it just jumps. Or it does the other one where it does the call and the data follows it. Except key exception reports, I didn't bother putting an example in here, because I kind of believe every one of you has seen at least two. And if you haven't, I don't know which code you're running these days. But what they basically are is you take what you would normally, as a programmer, grab out of a process dump to get your basic debugging information, your registers, some memory dumps, and all that sort of stuff. And you just put it out in a nice readable, printable format, formats that you normally need it in. Like for most of us when we're debugging, we need 32-bit values, and we also need character values. These days, because we're not doing too much 16-bit code, we don't need the 16-bit values. Now we can get them if you want them, but the thing is, just in general, and also what we do is we dump the areas that our registers point to, which are typically the blocks that were in use at the time when the problem occurred. So if you're lucky, you'll have non-gibberish data that you're pointing to that will tell you what's wrong. So and it helps a lot. Plus you also get a combination of a stack trace, which tells you who called when to who. Because often, if you pass bad pointers, any of you have programmed, you've seen the trap happens in the string copy, not in the guy who passed the bad value. And so, but with the stack dump, you'll be able to find out who actually started the problem. And sometimes, though, unfortunately, because of the nature of how PC instruction set is, they don't always give us what we call stack frames, so we can't trace them. So we do a secondary dump where we just find things that look like labels on the screen. And those of you who have sent me things without that nice little listing, add badge, trace thing, you get the standard response, install the symbols. So that I don't have to do that decode by hand, because I'm lazy. That's why we got the code. But the end result there is why you can basically read between the lines and decide which of these labels you're seeing are really the ones that matter. Because sometimes the labels appear just because it's a random number at this point in time. It's something left over or something like that. But it's all information that's easier to handle than starting with the process dump and doing all the decode by hand. Okay, GCC exception report looks a lot like the process dump exception report, except much worse. Because the problem is he left out a couple things that I always need. And maybe the next version of KLibC will add that in if we remember. I think I got a ticket in for it. But it's just missing stuff here. And I don't, it's odd. I just don't understand why you did that. Because it's not his style at all. So for anybody who's not a programmer, this stuff is meaningless. But even if you're just a C programmer, you see enough of it and you figure out how to use it eventually. Workplace, okay, they get written to either EWTrap.log or XWTrap.log. How many of you just use XWorkplace and overwrite eWorkplace? For you folks, it's all XW this, XW that. Everybody else, they want PWs. And this is what I was saying before. These two really share similar parentage. And it should go to your log directory. Or if it has trouble for some reason, right into the log directory, it'll go to your group. And there's usually a beep that goes along with it. This one here, yeah, that goes to the root of your root drive, and you won't see too many of them anymore. Back in the earlier Mozilla builds, we made extensive use of this library so we get good anti-aliasing. But Firefox is now based on something we call the Cairo libraries, and we just don't use this anymore. And Lars actually wrote an application to get rid of it so that nobody would use it when they should be. And the folks that are still using it haven't found Lars' tool yet. Now, the one downside of a dump is it's static. And also, depending on the type of trap you have, it may happen too late. The data that actually caused the trap and the problem that actually caused it may have happened long ago, far, far away. Now, for that, you need other tools. One of them that helps sometimes is tracing. And there's a number of them. One's the OS2 trace facility. And that is built into the kernel, and it's extensible to a point, and it works. For some reason, typical for IBM, it's not finished. There's just places where they claim to have trace points and they're not there anymore. And there are ones that don't. And the only reason I know this is there are ones I actually wanted sometimes. And what it's turned out to be helpful though, because over time we put tracing support into the various drivers that need it. Because the other problem is you got a driver that's doing a whole bunch of stuff, and it doesn't do it right. How do you know? You know that it's not transferring buffers, but unless you can actually see the sequence of what happened, it's hard to infer what really went wrong. Now, if you're in the kernel debugger, you just step it through and all that. And that works okay, except when your problem is timing related. And for that, trace helps. I know Lars has made good use of that with this stuff, just found problems that are just hard to find otherwise.
When you tell us to trace in a driver, you'll give us some magic sort of number. Trace, and then give us a number for this driver or a number for that driver. Is there any directory to what those numbers might be?
Yes. IBM, those are user-defined though. The directory is in the README that it gives you. But for all the other ones, in the system trace, those are documented in the os2trace.ipf. Now, the bad news is IBM, for some ungodly reason, when they did MCP, took all the good information out of that IPF. And so they just give you how to run the thing, and I don't know, and there's a couple README text files for the other ones. If anybody needs it, I have guides that I've compiled over the time that have what I consider as complete as what I know is complete. Plus, I keep copies of the work for one around because it's searchable and all that sort of stuff.
Okay.
Another tool is OS2 Trace and PF Spy. Let me go down here a little bit. So, a little more back up here, a little more detail. So they have mentioned these guys are available for me. They're on my site. For those of you who don't know where my site is, it's home.earthlink.net/P53 and then hunt around. And I also have an alias from www.mortcave.com for that too, which you'll find me. And of course, I'm always available by email. Some of this stuff will be moving to a better site someday when I get around to it. Unlike some of you, I can do web work just fine. I just don't do it. I find other things to do first.
Good enough.
Yeah. And let's see, what else? And I keep saying that these two trace points, this has been here for years, and I still haven't rebuilt the PDF files to no-op them out. But no one uses it, someone tells me I tried to use this trace point that failed, then I'll fix it. Sort of like a need thing. But I know not to enable it. And that's why I didn't fix it. Wasn't on the top of their list. And I have a little tool that basically makes it easier. Because one of the things I will say about OS2 Trace is for anything resembling, except the simplest usages, it is a pain in the butt with the command line. These are easy. It's like OS2 Trace on 16 or something like that, or 23, whatever it is. But for anything else, when you need individual trace points, it's bad. So I basically put a little wrapper on there that goes on and turns on the formatter, turns on the trace with the standard size, and reads a config file which has the trace commands in it. And I give you lots of examples so you can cut and paste and all that sort of stuff. Because the examples in the trace reference are not really human readable. They're readable, but you actually have to know what you're looking at. While you're looking at it, you're able to use it. It's not. Okay. Now the OS2 trace is done by my guy by the OS2 Black. And basically what he did is, okay, let me tell you why the downside is. this one, the good side is it's much more complete. The downside is that it's intrusive. It modifies your program, which is not a bad thing. You just take a copy, and let it modify it. They'll actually unmodify it too, but what I do for safety is I just take a copy, back up anything I'm going to let it modify. And what he has done is he has good, very nicely human-readable decode of every API. Basically, he's got the forwarders for everything. For those of the programmers that are wondering how they do this. And it's easy to use. I have a little GUI. It has a GUI setup wrapper, which is pretty easy to use. You just say, oh well, turn on tracing for this executable or this DLL, and then you have a lot of control over which items that you want to do it. If you need command line stuff, there's a command line tool for it too. And it does, the only limitation it has is I've had some trouble with 16-bit applications. Because it's a 32-bit application, it wants a bit more stack than some 16-bit applications have. It's a little blown up. But for 32-bit apps, I've had no trouble with it all. And you get these nice monsters, easy to read trace files, which are controllable if they don't, so they have what you need. And you can get it in Hobbs, and it's also available with Dave's homepage. And what I'll do with this thing is we'll put this up, and these links should all work right. And I'll go through it again and make sure. They were good the last time I looked. Now, for those of you doing GUI work, and you're having windowing problems, what you may need to use is PM-Spy. PM-Spy basically does a really rough trace of your GUI activity. Message, data 1, data 2, so on and so forth. And with window message, data 1, data 2. A lot of hand decode, but good control in terms of what you want to see. So if you're things with Windows on drawing and stuff like that, usually that's good enough to figure out why. You see, figure out who's sucking up the message and not letting it go on. Or at least you can see that the message is getting lost and then go from there. But it's definitely a programmer tool for interpretation. Easy for the end user to use. If you can just tell them, okay, turn on these messages, turn off these messages, or send them a new file. But definitely not something that somebody who doesn't understand GUI programming can be able to read. And it's on Ian's OS2 site and other places. Now sometimes you can get by, but you don't need this full real-time tracing. All you need to do is be able to see what happened over time. That's logging. Typically, logging just grabs events of interest and writes them to a file. You'll see that in a lot of apps such as System Error Log, which is built into OS2. Mozilla has a log facility which doesn't need as much use as it used to need, but it's there if you need it. And it's very, very complex. And very, very configurable because Mozilla is a huge app, so it's got tons and tons of opportunity to write data. eWorkplace has logging. KLabC has logging. And so, but you have to use the logging DLL for that. It's not built into the standard DLLs. TCP/IP has a syslog facility. Now that's application dependent. And things like bot library have to get a log too. Again, less use for that these days than in the past. System log entry, I view that as like a mini process dump. But the problem is it's one of these good ideas that IBM never really documented well externally. There's actually quite a number of apps that use it, but finding out what they're actually using and also making sure that and having them actually use the current version is sometimes harder. So it's there. I mentioned it because it exists as part of the kernel, but I don't use it a lot.
What's the system error log data?
Oops, where's that?
Yeah, where's the data file? If someone says
Oh,
I blew up, and I say, mail me your system error log, and I file it, tell them to mail.
Oh, it's in OS2 system.
RAS.
RAS.
Nice. Okay.
Yeah, it's those,
Normally you can put it anywhere, but by
Yeah.
default it's there.
Yeah, no, they won't have moved it. Okay.
yeah.
Yeah.
And of course, you can use, if you're lucky, PMDF will format it for you.
Okay.
Because PMDF is one of its not well documented features is it does read those dumps
Yeah.
sometimes. And I haven't figured out whether that's a PMDF bug or end user bug. I think it's just one of these things, it's just not really fully stabilized. You know, it works for the App Store, it works for, they need it in, and so on and so forth. But the thing is, the nice thing about it is that it is there, you don't have to do regular log file IO and all that sort of stuff. And the document, you know, the documentation's there, but it's reference documentation, not tutorial documentation. Mozilla log facility, hopefully none of you will need it, it's just good to know that it's there, so if anybody tells you, you've got a problem, say, well, turn on the Mozilla log and do this and this and this, you know, you'll know what they mean. This, you'll get off now. They'll go to your EWP log directory, and for some reason, they're written to the temp directory. One of these days, I actually have to put a ticket in to ask to get a move to the logs directory. But this was written long before we had log directories. And I'm not sure why the change was made from hwtrap.log. It does go to the log directory. Although I think log is the wrong name because I think we use log files. But I don't think we have a log directory, do we? Well, that's bar log, that's not for the environment variable.
Oh,
That's
yeah,
it,
it is
those
environment
logs,
variable.
yeah. So I think that's out of sync too, but if I ever mention it to Paul, it'll probably get fixed. KLIC log, you can use their DLL, and there's no control. You get everything, and it's huge. But if you have an easily reproducible test case, it can be handy. TCP system log, that is, you know, the standard in every TCP stack out there. And most applications that are network related, TCP network related, will write to it. It's just, you know, writing TCP/IP apps, you use the syslog. This is there. And we have the IBM version. I prefer the syslog v3a. It's just easier to use, and it seems to be more configurable. And that's pretty much it for that. Yeah. The log, and the other benefit of the log files, they can go anywhere. So yeah, they can get pretty big, but it really depends on the application. If you're using syslog or Apache, you get large. Intertech font line, I just simply mention it because it's there. The login reg key, and you got to use regedit 2 to turn it on. But I doubt very much anybody, at this point in time, anybody's ever going to ask you to turn it on again. A little more on the process stuff. One of the problems we have with our pop-up logs is, again, it's like everything else, is the point in time when you track, which may or may not have any relation to when you really have a problem. And sometimes accept queues not enough, so we need to process stuff. And the person who's helping, I have wrappers to get it set up, but typically, you know, if you're not a programmer, you need to program and interpret it, and they'll help you with it. It's easy to set up. You just say, turn it on, and where the dump files go, and then make the trap happen.
You have dump processor, pdump user, you're saying happens on exception, but can you just say, I want to dump right now? I don't know
Oh, yeah,
what
yeah.
you're doing. Just
Yeah,
leave
the
right now?
process, the
Okay.
command line process dump CLI has that ability.
Okay.
And this thing here will wrap that for you. It gives you a little menu.
Okay.
Yeah. If we have time later, I can show you some of these things in action. Trap dump facility. Same problem. Sometimes, well, actually, they're not really the same problem. This is almost invariable. The place, when you get a IPE and you take the picture of the screen, or you have, that's not enough. You really need to track them, figure out what's going on. And it's the same thing, track up records, set it up in config sys, or set it up in command line, which is the preferred way. If you're not getting the dump at startup, there's no sense having track dump set up or even process dump running in your config sys. Because otherwise you probably forget it's there and fill your disk up with files for little programs that get dumped every now and then. And this is an old thing for those of you who still have a floppy disk on your system. Way back when, what happened is, before we had,
Control, number lock. Always wants the floppy.
right, even if you don't have one.
Exactly.
But what he wants is a real mode program. It's not going to check for the floppy, doesn't have enough space. But back in the days, before we had enough disks to do track dumps, because there used to be, there was a time when, your disks were full, and actually finding a place to have a partition for the track dump was hard. But not so much anymore. Now it's just the hardware is getting us fixed, so we can't get the track dump when we want them. But eventually it'll get fixed. But what dump trap screen did is it basically read that first diskette and found the trap screens in it. And it was, but today everybody has a camera. So now what I get is I get these cameras which are these pictures that are totally keystone, which I can't run through OCR. When I go, could you put a tripod on that thing and focus it? And it's even better than that. I get this wonderful background, this tiny little screen, and you run it through Boss 2 trying to clean it up, and you end up, it's just faster to write it down by hand. Or keep the picture. But there are some, sometimes for known problems, those trap screens actually are useful. For instance, for those of you that have video problems that would get the trap where we try to go to the 32-bit PCI BIOS that wasn't there. We recognize that one immediately. And we just said, no, you have to run ACPI on this system. Well, ACPI replaces the missing BIOS code. So you don't trap it. And you have video. It's a good thing. Okay, now once you've got these dump files that you keep talking about, you've got to be able to read them because they're just some ungodly binary format, which is really hard to read. And the reason I know it's hard to read is because PMDF can't read it half the time. It's just, it's an interesting format, but they do what they did. And basically PMDF reads them in, and it gives you an interface that is a combination of extended menu options and something that's the same commands you use for the kernel debugger. But bottom line, you can dump the memory, you can tell it to dump the stack, it'll do some of the search stuff to find the labels on the stack and all that. And it's generally an indispensable tool for looking at static dumps. And there's no replacement, which was what makes it indispensable. Now, there's a bunch of other little things that IBM has thrown in over the years and advertised to some level or not, which is very handy. One of the ones I've very often mentioned to people is Thesus. Thesus is for figuring out what's going on with your memory and what's loaded and how much of this and that you're using when it comes to memory resources. If you're running out of memory, and all of a sudden your system says I have no shared memory, you want to figure out how. That's to answer that question pretty easily. It's got that linear memory usage screen, which is readable, and you just go down the columns and find out who it is. Fixing it is not necessarily easy, but you can't fix something until you know what the problem is.
It also has a disassembler.
Pardon?
It also has a disassembler, which really.
Yeah, that's handy too.
Really helpful.
Yeah. Not the best disassembler, but it's there and it's good. It's just another of those tools. PStat has been around forever. It just basically dumps your loaded executables and DLLs and a couple other things. And it's handy sometimes for finding what's loaded. I find these days I can use VS files and grep more often because I'm looking for specific things rather than an overview. If I want an overview, I go to Thesis because it just gives a much, much better picture of the whole thing. And there's an equivalent, there's I think it might be PS Sims. I gotta go think about that one. And I forgot the S on that. But PS Sims does the same thing for Semaphore. That's pretty much a programmer tool.
Yes.
Because who knows who's using that Semaphore? And I've actually recently implemented a couple of other pieces of code that for debugging, experimental debugging tools that are along the same lines. One is monitor SEMs, and it's basically just a DIO app that goes out and tells you what SEMs get created and released and all that sort of stuff. This actually came out of somebody claiming that their system is leaking semaphores. And we won't name the individual because he always has problems. But those of you on the right list know exactly who I'm talking about.
Sounds good.
No names. He's not here to defend himself and tell us he's doing everything right. But he's right in the sense that we do leak semaphores, but not at the rate he leaks. And it's really hard to do it. It's probably running here right now. It's in the background. I think I got it set to start up automatically. And there's another one called Monitor Threads, which we sort of use to help Peter Boylan find some of the thread leak problems. Because the threads are supposed to go away when you dump them. You know, thumb live forever, but so that, and those are all using the same API. There's an API, and there's also another program here that got the add for the list called SID2. And they all use the DOS query sysdate API. And it basically gives you gobs of data about a static snapshot of what's going on in the system. What's loaded, what's used in memory, threads, this and that. And you can just slice and dice it to get you the information you need. Of course, you actually have to know what you're looking for, but it's easy to use and it's just a handy tool. Then there's the Venerable Top, which has a new release for those of you who haven't been paying attention. Yeah, Paul finally decided he wanted to put hard kill in there. So if you remember to use that kill before the other kill, you might be able to kill some apps that used to be unkillable.
Cool. Wait, before.
Well, here's the problem. If you use a normal kill, the exit list runs. And of course, once you're stuck in the exit list, you aren't leaving.
That's right. Okay.
One way in, no way out.
So it plugs the exit list first, then it does it?
Yeah. Well, actually, it just bypasses it.
Oh.
It's just another form of kill that says don't run the exit list.
Yeah. Okay.
And actually, I haven't really looked to see how he does it. I don't know if there's a DOS API for it or if it's something that's in DOS.sys. There's an IOCTL that does it somewhere. It's again not documented. But most of us know about it, right? Because CAD-H has it too. If you use CAD-H and boot it up,
I think it's even a device, device helper command.
Yeah. Okay, so use CAD-H.
yeah, you do list.
Oh.
You got kill and hard kill.
Right.
But,
That's been there for a long time.
hard,
That's always.
oh yeah, but it hasn't been in top. And top is more accessible to most people because it's a straight command line app. It's not top operating like that.
But, I mean, that comes up in top if you.
No,
No, top looks like, you're thinking of something else. Top looks like
This
this.
is top, yeah. Wasn't it top?
It's also stop.
Oh, so top is just that one
Yeah,
small part?
this is 2.12. It's
No,
I see.
Now, what was it that had the hard kill in it?
I see. I didn't know.
Now, the thing I have to look at is this kill may, this is probably still the regular kill. Paul has a P kill. That's distributed top, and you probably took the option to do the hard kill there, which means you need some other way to run it. I don't have anything I want to show right now.
Well, what'll happen if this is the new one, and you hit kill right here?
Does it ask? Oh, okay, I haven't looked at it. I haven't tested, good. Okay, so he did put it here and no heat kill. Good, good.
But is this a hot kill, this kill? Because most of the time it doesn't work.
Well,
The only reason it doesn't is because you got problems that it can't kill. It kills for me all the time because for one reason or another, I am lucky enough that I very rarely get things hanging in the exit list. It's one of these educational things. I know what I do that will cause things to hang in the exit list, and I avoid doing them automatically. So I just, not 100%, I'll get, because there are, I do have a repeat every 4 or 5 days, or something, I do something like that. But if I'm a good boy, I can make it about 2 weeks before, the system, I just do things that are too hard. Then the PM and the WDS won't clear themselves out. But that's what I'm doing development and stuff like that. If you're just a desktop user, an OS2 box should stay powered on for months. There's web browsing and stuff like that. That stuff doesn't hang in the exit list. Flash will, but just browsing. And that'll go away eventually. But the problem with that, of course, is like as I mentioned, you can't hard kill after the fact. And there's actually more kill forms than that, but no one really knows about them unless you use Stardock's Process Commander.
I used to use a tool from Perez.
Yeah, he had a couple extras too, but he didn't have as many as Process Commander.
Yeah.
Let's see if I can bring this
It
thing
looked
up.
like top, but yeah, so that's probably
What do I do with it? Forgot to add this to thank you. I have it on the menu of the other system where I can bring up Process Commander full screen from here. Which makes sense because when you're here, you're running critical priority, which means you can actually run. Yeah, that's something I had played through many years ago. When we first implemented things, we didn't run this critical. They try to pop it up and something's chewing up, it wouldn't come up, yeah. But now we run the critical and the other. So that also means when you run top from here, top is running critical too. So it doesn't have problems with performance.
Wasn't there a device driver we could load for hard kills?
Yeah, I think STD Help has one, there's a couple of them like that.
There was an accessory thing to WatchCat that you could get. You had to pay extra for it, I think, but it would allow you to use something like a game controller or a switch that you connect with a serial port.
Yeah.
And that was effective. When we were set up for that, I tried it a couple of times and it worked, but it was.
Oh, it worked.
Unless we were debugging like with RSG.
Yeah.
It was real handy.
It's real.
How are you sitting around?
Yeah, a lot of that stuff is out there, and it's still there and it still works in some systems. And actually, Process Commander is supposedly a successor to that, but they'll never really admit to it. Because I think they had a falling out during the development process. And let's see, first developer types, we like our developers. Because there are times when you just simply have to step through the code because we're not smart enough to see what it's really doing without watching it do it. Yeah, exactly. And the lowest level, we've got the kernel debugger. And the big problem we have with the kernel debugger is there's only 2 interfaces to it. One is the serial port and the other is network. And the network only runs once the network's up. But however, for certain types of debugging, it's fine. In other words, let's say you have a USB driver that you're debugging and it's booting and all that sort of stuff, but it has performance issues. You can use network debugging, assuming you don't have a USB attached network card to debug that. Now, what the rest of the world has these days for kernel debugging is they have a very expensive USB cable that plugs into EHCI debug port, and they run the kernel debugger that way. Every now and then, David and I talk about what would it take to make that work. it's hard to know, it's one of those, because the serial interface really isn't using interrupts, it's polling, so, it seems like you should be able to patch in there fairly easily.
I might have a resource that might understand that.
What, the cable itself? Cable's
No, the code. Not for our OS, but,
yeah, so the other OS is easy. Code's there. Yeah, the biggest problem we have is that, source code is not there, really. There's a new source code, but it's not the same as we're running. So anybody who's looked at it, that knows the code looks like, knows it's not the SFP, not even close to the SFP code. So it's a time in the sense that we have to name things and know what they're intended to do. But a lot of times it's just as easy to come with a bug within and watch it to understand what it does. Because most of the time, the use and the meaning of the data is fairly obvious for what you're doing. Not always, but, The other one that would be fairly accessible from is open Wi-Fi. Good source level development for GUI apps and VIO apps. It has some problem with PM apps, but those you can solve by doing remote debug. Basically, you run it over a TCP/IP link where you have a host running the debugger and then you're not running the application under test. And that solves all the GUI problems. It has some problems breaking in to running apps, but usually you can work around it. Especially if you're running remote because you can get in other ways there. Then there's the visual H debuggers, which you got visual H, you got visual H. One of the things we can't do yet with the Open Watcom debugger is debug applications that are used that have IBM debug data. Open Watcom supports more. We can generate debug data, but I've never gone through the testing required to make sure that we can actually use that debug data in Open Watcom. It's doable, because that's all plug-in stuff. But it's just, and you put the code in there, but I need to test it out after I converted the patch. I don't really know how much of it made work and how much was just working process for it. Because he did the patches for debug data for the same reason I did, so that you could use the Visual Age debugger to debug Mozilla. Then there's the ICAP debugger. The ICAP debugger is nice because it gives you the ability to source level debug device drivers. Yeah. Lars uses it quite a bit. And over a network, it's not so great over a serial interface, but over a network interface, it performs pretty nicely. It was essentially, I believe that it was really developed for video device drivers, for video driver development. Because they're DLLs, they're running Ring 3, and their performance problems can easily be analyzed once you have the network up and running.
Is there a reason that adding the crack debug code to the Wacom linker rather than just using the Wacom debug in just GCC, too hard to add to GCC, or?
I never really asked that question. I thought about it, and then we really thought, they could have just used work data and used Wacom debugger. But it may have been that they were having trouble with Wacom debugger, and they just looked told. It was one of the things where I have a tendency sometimes when somebody asks me to do something, I don't always give them all the alternatives. And it was something I wanted to do anyhow, because I knew it was sort of, we needed to do it because we needed to use the WLAN.
What is, when you do GCC coding, what is the debugging situation there? Does that write?
That with GCC, if you use WLAN, you can use Visual H debugger for it. Because we will generate IBM debug data for your GCC app.
That's a command line switch? Or no, WLink is a linker. Okay.
Yeah, it's a link,
okay.
but you still have to tell WLink at some point in time to generate IBM debug data as opposed to Dwarf or anything like that.
And does it come, what about like GDB, those Linux style tools?
We haven't had a good GDB port since the EMX days.
Okay.
Yeah. It would be nice because The problem is though, GDB alone is really not quite the good solution. We need GDB with like a Qt wrapper.
Right.
That's how they do it in the rest of the world. And maybe when we get a good Qt, we'll actually be able to do that. Because there's no real reason that we can't implement GDB. The DOS debugging interface is good enough to do that stuff.
Just a question. So the newer GCC compilers generate IBM type debugging for?
Not the new one, the old one. It's been doing that for many, many years.
I thought they generated something that some other debugging for type.
No. ZOMF has been doing IBM debug data forever. As long as, and ZOMF has probably been around, I don't know, 30 years life. No, quite that long. But it's been around for a while. Ever since 321, 322. ZBLL, ZOMF.
So in the past, you could always
Well, that's how not only in the past, that's how we could do it, that's how we did it. Because otherwise you do printf debugging, and that's no fun.
And another question is, all those -z parameters for GCC, where are those documented?
They're documented in the READMEs.
Or they come with the compiler?
Yeah.
Okay.
And I have some additional documentation. I don't know how much of it I've actually posted or not, but I tend to collect and organize in ways that work for me, and it might work for other people. And then somebody mentioned disassembler for the places it's there. PMDF also has a disassembler in it. And one of the ones I use a lot for when I need to analyze code that I don't have source for is IDA. And it's pretty handy. I actually still, to this day, use the ancient DOS 3-something-X freeware version. And there's one or two instructions that won't disassemble properly, but typically it's like some of the float saves and things like that. And what I could use is I could go get the Windows version if I actually had a Windows install and run the last version, which would do that, which would work fine too. But this thing is perfectly capable of fully disassembling the compiler. You won't, obviously, because the compiler has a lot of data that looks like code, you won't get anything usable right out of the box, because it just doesn't have no way of knowing. But IDE is pretty good. IDE has always been pretty smart. Of the disassemblers, I find it the most intelligent. It does the right things most of the time. You can confuse it, but once you go fix it, fix the parts that confused it, then it sort of picks up and goes and not a problem. There's certain, like, it has terrible time with Modular, since we mentioned Modular. Because Modular does a lot of jump tables where the jump tables are in line in the code. Couldn't put it in the constant D group, So it's little things like that, Of course, the other thing Modular does too is they don't know what a string is. So if you get short strings, they use move statements to build the sucker up. You try finding those things in the code. And you wonder why I'm not present. Okay. Well, final thoughts. Well, I mentioned this right in the front, but I'll mention it again. OS2 debugging camera. It's just plain handy, It's in IBM's way they actually document all the system tables. Unfortunately, the report layout, the SMP stuff is not accurate, but if anybody needs them, I have some of them.
That was a red book?
Yeah, that was a red book in this day and age.
So you can probably still get it, actually.
Yeah.
Yeah, they have all those really old ones are still around.
Yeah, now you can even get it in PDF format.
Yeah, that's what I mean,
I think it's still there in the Red Books library.
They don't seem to remove stuff.
Well, like I always tell people, the internet never forgets. Even wrong stuff.
Except in Europe.
Yeah, right.
Really? What's the rule there?
Google, yeah.
They have a new rule.
They got to delete
They
that
told them to
for 2
back
years?
off, yeah.
The debugging handbook is on CD1.
It's in the toolkit, so it's probably in the second CD.
Okay.
And it's also, you'll find it if you Google for it. There's a bunch of people have it in their repositories. You just need to give it the right name. in and get a place to go look for my junk. And it's like, you keep whining here, try to develop a community. Do something. We don't even care if it's right or wrong. Just do something.
Andy,
Am I out of time?
are you ready?
I'm done. You're unless done. Where do you want me to start?
You ready to go?
Yeah.
Oh,
Okay.
yeah. You're looking at me.
I want to thank you, Steve, for swapping positions to give Andy time to get things straightened out.
You think? Straight down.
Normally, we're at what would be
Done.
the final time for the day. I would like to have Andy complete the presentation today, and we just go a little bit late for...
Turned it into a file named URL to a Mozilla starter script, which figures out which version of Mozilla I have running and passes it along with the proper parameters so you don't get any stupid errors, like trying to open the log twice and all that sort of stuff. And then all these sessions die. But not everything goes away. Our friends, the semaphores are still open and owned by the VM shell, which is not good. You do that a lot, you will eventually run out of your 65,000 semaphores. Now, this thing actually, and it's, so, you know, and if I actually go look at those semaphores, or force a process dump and go look at the semaphores, yeah, it's doing a real, it's waiting for something to happen. It's waiting for an event, and the event's just not going to happen. Probably because whoever is expecting to post it is long gone. Get out of here so everybody doesn't die of hunger.